Welcome to Spring LIB.
In this question, there is a 36 kilogram crate starting from breast and is pulled across a floor with a constant horizontal force of 225 newtons. For the first 11 meters, the floor is frictionless. Okay, so there is a scenario that this is the box. It is pulled with 225 newtons. Over here, we have the distance traveled is 11 meters, and this is frictionless. And for the next 10 meters, the coefficient there is a coefficient of friction. So over here, there is some friction acting on it on the floor with the coefficient of the kinetic friction as 0.2. So what is the final speed after 21 meters? Okay, so first we need to find the initial speed is 0, by the way, over here. Okay, so what we can use is since we are given the mass of the crate already, so we can find the acceleration. So I think for the first stretch, let's call it A, B, and C. For the stretch of AB, we can use the third equation of motion, that v square is equal to v naught square plus 2as, where this is v. So the initial speed is 0 plus 2 times acceleration is force, which is 225 over mass, which is 36, and s is the displacement, which is 11. So let me just grab my calculator here. It's coming as 8.29. So that's 8.29 meter per second at point B. But we need to find the speed at point C. So now we're going to do the same work, but for the stretch BC. Okay. So now the difference is, although there is still a force of 225 Newton acting on it, but there is a restraining force of the friction which acts over here. This is the normal reaction and this is the weight. So clearly the normal reaction will be equal to the weight, that is 1, and the acceleration is going to be 225 minus F. This is the net force, and this should be equal to ma. So the acceleration is going to be 225 minus friction force, which is mu k times normal reaction over mass. So that's going to be 225 minus mu k times normal reaction is weight over mass. This is the required acceleration. So if we plug in all the values, we have 225 minus 0.2 times weight is mass, which is 36 times g, which is 9.8 over mass once again. So we'll get the value of A from here, which is 36 times 0.2 times 9.8, 225 minus answer over 36. So that's coming as 4.29 meter per second square. So again, we can use the third equation of motion to find the speed at point C. So v square is, let me use a different color over here. So v square is v naught square plus 2as. But the only difference is there is an initial speed v naught, which is 8.79, which we just found, because the final speed of AB will become the initial speed for BC. So that's 8.29 square plus 2, 4.29, and the distance is 10, because the next stretch is for 10 meters. So let me just again grab my calculator here. So we're getting 12.43 meter per second as the final answer at C, speed at C. Thank you.